Welcome to Interface Segregation, the forgotten I in S.O.L.I.D. The S.O.L.I.D principles are 5 suggestions or recommendations of how to write clean code. Single responsibility, open closed, list-off substitution, interface segregation, and dependency inversion. And I think these are approximately how often people talk about the various things. If you don't recognize these principles, you have some homework to do, looking up on Wikipedia, where they've got a pretty good guide to them. But this talks about interface segregation, particularly how it applies to PHP. So, allegedly it's important to introduce yourself. My name's Daniel. I'm the maintainer of the Imagic and Gmagic extensions for PHP. I occasionally write PHP RFCs to improve the language a tiny bit. I have an open invitation if anybody wants help writing an RFC, or at least help getting it for the process of getting it through PHP internals. It's something I've done for a few people, particularly people for who English isn't the first language. But more importantly than these qualifications, I have a beard. This is a diagram that shows how trustworthy beards are. As you can see, I've got a nice full beard, so you can completely trust everything I say. Don't need to question it too hard, and definitely don't need to have too many tricky questions at the end. Thank you very much. So, what is interface segregation? If you go to Wikipedia, there's this definition: many client-specific interfaces are better than one general-purpose interface. That's true, and using interface segregation leads to several benefits. It makes your code easier to test, makes you more productive, admittedly after doing some setup work, but more importantly than everything else, I think it makes your code more reasonable. There's two different things. Code can be reasonable and code can be understandable. They're not quite the same thing. Reasonable code, what the code is doing is obvious from reading the code. Understandable code, you sometimes need to read the documentation, or you need to ask a colleague what's going on. So for example, this is the constructor for the MySQL.I class. It takes a host, username, password, DB name, and port. You can look at that code, see what the parameters are, and make a pretty good guess just from reading the code what is required to construct that object. This is the constructor for the S3 client. It takes an array of stuff. You can't look at this code, you can't reason about what's meant to be in the config. You need to go and read the documentation, look at an example, or ask somebody who's already used the class what needs to be in here. The second difference between reasonable and understandable code is that for reasonable code, errors happen at the boundaries of execution. For understandable code, errors can really happen anywhere. So here's some code that's got a bug in it. We've forgotten to pass in the password, database and name, and port when creating the MySQL.I object. When you run this code, when the execution gets to this line, there'll be an error will occur, and we'll see the error message saying missing parameters on this line. And we can read the error, see exactly where the error occurred, and then go and fix it. For the S3 client, we make a typo in setting up one of the parameters. We've misspelled password. When we run this code, there definitely won't be an error on the S3 client factory line. There'll be an error somewhere else. Quite possibly when we actually go to use the S3 client object and actually try to upload something, we'll get an authorization error, and then we'll need to work back from that authorization error to this line of the code. And that's much harder to understand. And the third difference between reasonable and understandable code is reasonable code, that the parts are simpler, but there's many more of them. For understandable code, there's fewer parts, but each of those parts is more complex. And you'll see that from the rest of the talk. So first thing we're going to do is refactor some code. But just to make sure that everybody understands what I'm about to talk about in a moment, I want to make sure that everybody understands what I mean by a mock object. Mock objects are used as a stand-in for objects which do not exist yet. They're used in tests to make sure that one bit of code calls another bit of code correctly. In this example, we're creating a mock object that will have its get URI method called, and it will return the search string, return the string search. If the test doesn't call the get URI method, the test will fail. So this is the code we're going to be refactoring. I've hidden some of the details from you because I want you to look at the request object to begin with. Without being able to see the code inside the function, can you tell how the request object is going to be used by this method? Would it help you if I show you the methods on the request object? So these are all the methods on server request interface. We can see that it actually extends another interface. Here's the methods on those interface, and again this extends another message interface, and here's all the methods on that interface. So I've shown you everything there is to know about that interface. Would you be able to sit down and write a mock object for this test? And the answer is no. Even if you understand everything there is to know about an object that's being passed in, you've got no idea of how it's actually being used inside the function. You have to go inside the function, read where that object's being used, actually see which method's being called on it to understand what's happening inside the code. And that's quite difficult to reason about, in my opinion. So here's the rest of the code that we're going to be refactoring. It's a search controller where the request is being passed in, getting the query params, checking to see the search terms are set in it, throwing an exception if it's not, and then otherwise using the search terms to do the search. So these are the lines that we're going to refactor first. So let's start segregating. Actually, when you say segregating out loud like that, it doesn't sound so good. So instead of segregating, let's start extracting a type. So I'm going to extract a type from this code called variable map. All this does is has a single method on it that allows you to get the variable from the object. And because we're refactoring code that uses PSR7 request, we're going to create a PSR7 variable map. Here's the implementation of that. All it does is passes a server request interface in, and then defines the single interface. So the single method for the interface called getVariable. It's not particularly exciting code. So after we've done the refactoring, after we've created this object, we can now refactor the controller to use this object in its place. So the green lines are the previous lines, and the other colours are the new lines. Straight away, you should be able to see that the controller is now quite a bit simpler. We've removed a conditional statement from it, and it's got 3 less lines of code in the controller. The downside to this is we now have more components in the code. To be honest, I don't like mock objects all that much. I find them quite hard to read. Most of the time my IDE doesn't understand them, and it makes refactoring code be quite painful. For me, mocks should only be used when you have to test behavior. If you can, using a stub or a fake implementation is much, much easier for me. They unfortunately suffer from poor marketing, in my opinion, with not quite as cool a name as mocking. So we can create a stub implementation of the variable map to use in our tests. So for the real implementation, we were passing in a PSR7 request object. For the test version, we're just going to create a version of variable map that takes an array as the to hold the variables, and again we implement the interface to read the variables from the array variable map. We can also create a fake implementation of the data source that's used in the controller. So from the data source, we create a fake version of it called the Echo data source that just implements the interface and just returns the same search options that we passed in. So when we now use that fake when we now have the data source as an interface, we can now write a test for the controller that doesn't touch PSR7 object at all, and it's quite easy. It doesn't require a mock object, and we can test in the code that when we pass in some parameters to the Echo data source, it just returns us the options that we passed in. And for me, that's a lot easier to code and understand than having to create mock objects. We can also test the controller in the error case. So instead of passing in the proper, for this test case, we don't set the search terms in the array variable map, and we can test that quite correctly when we actually try and use that object. The expected exception is thrown. So that's a really fast, really simple introduction to interface segregation. All we did was move a little bit of code around and added some interfaces. For that small amount of work, the benefits are our controller is now no longer tied to a HTTP library. Because it's no longer tied to HTTP requests, we could actually reuse that code in a command line application if we wanted to. In my opinion, the test is easier to write and easier to maintain, as we can use a array implementation. The tests will run faster because the array variable map is a smaller object. It will actually take less time for that test to run. It's only a small amount of time, but when you have a few thousand tests in an application, having each of your tests be a tiny bit faster is a big win. But most of all, the tests are easier to reason about. There's a guy called JB Rainsberger who has a really good video, or really good talk, for which there's a video at that URL. And the talk's called Integrated Tests Are a Scam. It's a slightly troll headline, but it makes you think. It helps you think about tests and what they really are and what they really need to be. So he's talking mostly about integrated tests being a scam, but I think unit tests aren't really what people think they are either. So we like to think of unit tests as testing code in isolation. So for the unit test for the search controller, we like to think that this is the thing that's being tested. But that's not quite true. What we're really doing is testing this area. We're testing when we pass in an array variable map. So when we're passing in a variable map that has the search terms available, we're checking that the behavior is correct and the code works. And when we're passing in a variable map that's missing the search terms, we're checking that the exception is thrown. So when we're running that test, we're actually testing the interaction between the calling code and the code under test. And so I need to make that area bigger, because before, when we were passing in the request object, it was a really big object. It has many methods on it. And to understand what this test is doing, we need to understand that although this big object is being passed in, we're only actually using this single method, get query params, in it. After we've extracted the type and created the variable map, this isn't the situation now. For this test that we're thinking about, we're just passing in a variable map that has a single method on it. This is big, this is small. When you've got smaller things to think about, it makes your code be a lot more reasonable and much easier to maintain. So that's basic interface segregation. But I think the concept is actually can be much more widely used in PHP. Although interface segregation makes you think about interfaces, it can be applied to other things. So I'm going to change the definition of what we're talking about. Instead of interface segregation, the question now becomes, what is type specialization? And for me, the answer is many client-specific types are better than one general-purpose type. Hang on, I've mucked up my slides. Oh, sorry, I forgot what I was going to say next. So, many client-specific types are better than one general-purpose type, but I don't like clever words. And to me, client-specific is trying to sound clever for no particular reason. So instead of that, I'd prefer to say many small types are better than one big type. So in PHP, arrays are great, but they're pretty hard to reason about as they're a really big type in the sense of you can put anything in an array. When you accept an array as a parameter, although you might hope that it has certain, might hope it just has integers in or just strings, anything could be in there. You really can't tell. So for the code we were refactoring, before we were using an array for the search options. So let's imagine that there's a request comes in to add a limit to the API. Can anybody look at this code? So up here we've added to the search options a limit key, and we've set it to 50. Can anybody look at this code and tell me if there's a typo on the word limit that's been spelt with an E? I saw some nodding heads. You're sure it's a typo? We can't tell. I mean, if the programmer is French and limit spelt with an E in French, there's a pretty good chance that this isn't a typo. If they're an English speaker, it might be a typo. We just can't tell. If we wanted to find out whether it's a typo or not, we'd have to go into the method for search for items, look how it's actually being used, and check it there. So because arrays are such a generic type, it's hard to reason about them. So let's extract a type here as well for the search options. Search options type, again, not that very small object. All it does is take in some keywords and an integer for the limit. We can now refactor the search controller. Again, the green lines are the ones we've changed. And now we've got a type. Now we're using the search options type to hold the search options. This code is now easier to reason about. We can look at this code, see that it's going to behave correctly, and we don't need to go off and look into the search for items method to see if everything's set up correctly. So I hate it when I go to a conference and somebody like me gets up on stage and just says, "This thing's great, you should do this." Quite often when I go away and actually try it, I find that it doesn't work too well, or it just feels a bit weird. And I think to myself, am I using this right? Am I doing it wrong? But then once you actually go and talk to people who actually use that technology, you find out, yeah, that's one of the downsides to using this. It's something you've got to get used to. So as a warning, writing solid code does lead to a lot more typing. Yeah, you have to physically type out more letters on your keyboard, and there will be more classes. The main piece of advice I can say is you get used to this, and I'm not sure that I've met anybody that's started writing more solid code who's actually regretted having to type out more characters. The main reason being that readability is more important than quickness to type. Most of the time we spend programming is actually spent reading code and then figuring out what needs to be changed or added. The amount of time spent typing out characters on a keyboard is relatively small. I will have to say that if you use a dependency injection container to run your code or set up your dependencies, a lot of the pain will go away because a lot of the wiring up and creating of objects will go away. And I will say that although in the example we've gone through, we ended up with more lines of code, once you actually do type extraction, normally only have to do it once. So for in this example, the variable map would be reusable across all of the project. So although for the refactoring we did, we ended up with more lines of code. Once you actually do it across the whole of the project, you might actually end up with fewer lines. And no one has ever laughed at that part of the title, so I'm quite disappointed. The second downside is that solid code actually tends to be slightly harder to use. So here's two different bits of code. One's written in a solid fashion. The other one is written using dependency injection. When you look at these two pieces of code, they look pretty much the same when you're actually writing them like this. But then when you go to use them, the bad code is significantly easier to call. The solid code is actually quite a bit more difficult to use. As I said, if you use a dependency injection container to run your code, a lot of that pain goes away. But also you'll just get used to it, and it doesn't take that long to write solid code. If I had time, I would spend about an hour talking about dependency injection, but I don't have an hour to talk about it. I've got an example project on GitHub that contains all of the examples I'd like people to look at. And in particular, there's a README file for how to use the or injection library with Slim. So the rest of the talk is some advice on how to write good interfaces and types. And for me, designing interfaces is very much like drawing an owl. Does anybody know how to draw an owl? It's pretty simple. There's only 2 steps. You start drawing the owl, then you finish drawing the rest of the owl. Or to put that another way, it's really hard to give advice exactly on how to write good interfaces. It's one of those skills that you'll get better at the more you do it. And I'm going to give you a few suggestions on how to use interfaces and types for the rest of the talk. But before we do that, I want to change this definition of what is type specialization one tiny bit more further. So many small types are better than one big type, and naming your types makes them easier to reason about. Having names on things allows you to see exactly what it's going to be used for and where it's going to be used across your application. So the first types of interfaces are the trivial ones, the ones that you need on every project that do one or two things. Don't spend too much time trying to design these yourself or worrying about design. Just steal the design from any other project or from any other language. Write them for your use case that you need it for immediately. Throw them away or change them if your use case changes, but don't spend too much time trying to design a perfect interface. For all of the simple stuff, they should just be there and available to you. Do what you immediately need them to do and not try and be a universal interface. The second piece of advice is I strongly recommend that people use semantically meaningful types wherever possible, at least when that type goes across the application. So this is a reasonably common thing to have to do in an application. You need to write a temporary file somewhere, and we've got one function that writes a temp file, and we've got another function that writes an image temp file. Both of these functions take temp path as a parameter. Nobody in this audience could look at this code and tell me if these two temp paths should be the same, or maybe we need to write different directories for the temporary files. You'd have to go and look at the application config or ask a colleague of, should I be writing images to the same, temporary image files to the same directory as this, to the other temp file location. We can extract a type from this. Instead of passing in a string directly, we extract a type called temp path. Again, not a very complicated class. All it does is take a temp path in a constructor and returns it when we ask for it. And we could create a separate one for the image temp path. And now we can look at this code and see that these two temp paths are definitely different. If we ever mix them up and try to pass the image temp path to a function that expected the normal temp path, the PHP would give us a nice error saying we've mixed them up. There's no chance now that we can actually mix these two strings up because they have their own types. The second piece of advice I can give is to use types wherever you've got something that's crossing a boundary in your application. So by crossing a boundary, I mean going from one layer of the application to another layer of the application. So in these examples, we're sending an email. For one of them, it's for a registered user where we've got the name already and we've got the email address. For the other example, it's for when somebody's going through the sign-up process and we've only got their email address so far. We haven't got their name. There is a type in here, but you can't see it because we haven't given it a name. So we can extract a type from this, and we're going to give it the name of email recipient. And we need to make two implementations. Again, very boring code. One user email recipient that we create from a user object, and a second, a sign-up email recipient that we can create from the sign-up form data. And we can refactor the code that uses those, and we can now pass the email recipient type around. The benefit for doing stuff like this comes over time. When you want to add things like complying with GDPR and making sure that the user's been opted in, when you passing in an email recipient object, you can trace back from where it's used to where it's created, and then be able to say add the appropriate code in the user email recipient or sign up email recipient object to add a is user opted in, instead of having to look across the whole of your application to trace where stuff's coming from. Wrapping the origin of some data means that you've got effective kind of a stack trace of where it came from. Another piece of advice is to extract and name input parameter types wherever possible. So this is code I see quite often in people's projects of they've got a controller that's doing get articles and they've got the validation rules directly in the controller. Although this code works, I find it hard to read, let alone reason about. So for example, I don't know if I change one of these values of 10,000, do I need to change it somewhere else? Or if I change what the validation rules are for this code, do I need to change those similar validation rules somewhere else? There is a type in this code, but it's somewhere, but it's really hard to see. I strongly recommend promoting input parameters to be a type that's got a name and is visible across the whole of your application. I just so happen to have a library that does it on GitHub called params, which allows you to do things like this. So instead of having the validation rules in the controller, all the validation rules are contained inside the getArticle params object, and we can create it directly from environment. As I said, it's on GitHub, but it's off topic for this talk. The next piece of advice is to avoid big interfaces. So when the caching PSR was discussed, people were trying to make a caching interface that covered all of the use cases. So the caching started off with get and set, but then people needed to be able to set TTL so that the item gets deleted after a while. So other people need to delete stuff. Other people need to be able to clear the whole of the cache. Other people need to clear part of the cache. Some people need to clear part of the cache by regex. And the interface that was under discussion just grew and grew and grew. This is not great for open source projects. In fact, it's pretty bad. The problem it causes is that there's never going to be an agreement on what the right size of this interface is going to be. Some people want a really, really simple cache that only has a few of these. Other people's that have much more complex use case need all of these things, and there's never going to be a single definition that's right for everybody. And a whole lot of effort was spent trying to get this right, or spent trying to discuss it when there's never going to be a right answer. It's also not great for not open source projects. If you've got a application you're developing for your business, there's quite big downsides to using big interfaces that have all of the available methods in them. I once worked on a project where people were allowed to upload images, and because we wanted them to be available immediately, we passed in the cache object to the image uploading code, and we allowed the code that was processing the image to set the user's avatar image in the cache, so it was there available immediately. A few months later, we realized we needed to do some more work to allow people to change their avatar, and because we wanted the change to be available immediately, one of the developers working on that code called the clear cache function. That was the whole cache for our entire application being cleared whenever somebody uploaded a new image. And it proved to be a very effective way of doing a denial of service attack on our application. Because the clear method was already available in that interface, the change request to allow users to change their avatar was very small. If we'd done what I'm going to talk about next to break up the big interface, the change request would have been more obvious that this was going to be this change was going to be affecting more than we'd hoped. So instead of having big interfaces, what I suggest is breaking them up into individual items. So they have, for each of the things that were in the big interface, create a very, very, very small interface. What you can do once you've done that is to declare a interface that is specific to the thing that's using it. So for this example, we're creating a basic and delete cache interface that extends cache basic and cache delete. And a lot of people forget that PHP, although you can't do multiple inheritance for classes, you can do it for interfaces to allow you to define an interface that implements multiple other interfaces at once. Unfortunately, we now need to do a little bit of rubbish to make this usable. Hopefully when the union types RFC passes, a lot of this code will no longer be needed. And the next piece of advice is don't wrap other services. I think this is something most people, when they start learning about interfaces, it's one of the first things people do. They think, right, I'm going to need to mock my database. What I'll do is create my own interface that has all the methods that will be available through the MySQL class. And then what I'll be able to do is create mock or fake objects for that interface. This doesn't work out too well. The main reason for doing it, to be able to switch database backends easily, just never really works. What you want to do instead is to move the interface you create one level higher. You want to move it to where your business and domain types are defined. So these are types that emerge from your app's business needs. They're going to be the interfaces that create the most value for you, in the sense of making your code be easy to reuse across your application. They're not going to be reusable across different applications. I really strongly feel that trying to make business stuff be reusable across different applications is a fool's errand. It's going to take a lot of time, and it's just never quite going to work. Main thing though is that when you're creating this abstraction layer, it should cover just a small concept. It doesn't. So instead of creating an abstraction layer or an interface to represent the database, create an abstraction layer for just a small piece of database access. So this is something I had to implement recently. We've got a system that has payments going through it, and we needed to add some code to update the purchase with the processing cost fees after the purchase had been finalized. So to do this, I created an interface that all it does is finds purchases that need their fee fetching, can save the fee, or it can save that the fee processing failed. To be clear, this is talking to the database. This is my database abstraction layer. This interface does not have the word database in it, which means that it's completely decoupled from it actually being implemented in a database. I think for people who like big words, I think they might call this a root aggregate or something like what's the phrase? Aggregate view? Special word for it, doesn't matter. But this is just, without having to do event sourcing or anything like that, just when you're writing normal code, creating abstraction layers that just give a small view onto the database is much preferable than creating an abstraction layer that has all of your database access in it. So the final thing I want to talk about is something I talked a bit about yesterday, and that's how emotions affect how you program. Pretending that emotions don't affect what code you write or what code you want to write is not a good strategy. How does this code make people feel? If you wrote this code, would you feel clever after having written it? Is this code boring? Yes, this code's boring. Let me ask you a different question. Would anybody submit this code when applying for a job? If you hire me, I can take an array. I'll create a class that takes an array, allows you to take one item out of that array and returns it, or otherwise it throws an exception. Would anybody submit that as a code example for a job?
Just on its own?
On its own, by itself. If you hire me and pay me lots of money, I can write code like this. No. People would want to submit really clever code to make themselves look good when applying for jobs. I think this is the wrong way of looking at things. The array variable map is not clever code, and English is a terrible language and it affects how we think. When we see that code is boring, it makes us feel not so good about it ourselves. This is something you've got to work on. You've got to push through being able to write boring code to make your application simple. And because it's only when you start writing simple code that's easy to reason about across your application that you'll be able to write maintainable code. In the examples we were looking inside the function to figure out what the code was doing. Once we start using types, we can just look at the top, what's being passed into the function, and we don't need to delve into the actual lines of code to figure out what's going on. Boring is not bad. Boring is good. It implies simple. I want you to learn to feel proud that you have written simple code, but it's a really hard skill to master. And to make an appeal for authority for the end of the talk, the purpose of abstracting is not to be vague, but to create a new semantic level in which one can be absolutely precise. The intellectual effort needed to understand a program need not and should not grow more than proportional to the program length. That's my talk. Oh, if you can leave feedback at joined in, that'd be fantastic. One thing, if you can say one good thing about the talk and one thing that can be improved as well, it really allows speakers to focus on what people want to see more of and what people would like to see changed. Does anybody have any questions? The question was, are there any other quick wins for extracting types to make your code be easy to understand? And the answer to that is no, not right now. What I'd suggest more than anything else, though, is looking at places in your code that's where stuff's being passed across boundaries. I don't care if you've got some code that's just in a single layer and that just does a single thing. If internally it's using an array or strings, but they're not exposed to the outside world, that's great. Once you start passing stuff from one boundary, over a boundary from one bit of the application to another, I think you can actually look at applications. You can break applications down into separate applications. So imagine you've got a controller that's calling the email sender directly. Pretend that instead of calling that code directly, we had a HTTP layer in between. You can see that, hey, look, this is a separate application almost. We should be defining the types that are used by this API and making them be really clear to see what's allowed and what's not allowed. That's the place I'd look first. Any other questions? Okay, cool. Thanks for your time. If you can leave feedback, that'd be great.